So our lesson for 4.7 is using the quadratic formula and also part of the quadratic formula, which is called the discriminant, to determine the number of types of solutions that you're going to have. So what you're going to like about the quadratic formula is that it works for every single problem. So when in doubt, if you have to solve a quadratic and you can't figure out what method is the most efficient, you can always use quadratic formula, as opposed to completing the square and factoring where it's not always the most appropriate technique for solving. So first thing I want to determine is if I was looking at a graph of a quadratic, I should be able to determine the number of solutions and possibly even approximate those solutions. So the solutions are where your parabola are going to cross the x-axis. Those are going to be your real solutions. So I notice this parabola crosses the x-axis twice. So there are two solutions. And I could even go as far as to estimate them as far like decimals if I needed an exact answer, like a radical answer, if they were irrational, which these are. I wouldn't be able to help you out with that until we did some more work. But this is approximately like negative 3.5-ish, and this is, approximately 0.3, 0.4. So if we were matching up to like a matching question or a multiple choice question on a SAT test, that would be a good way to determine the solutions. Here, this parabola, it's kind of weird what happens, but it ends up bouncing off of the x-axis. And we saw this back in the solving by factoring lesson. That's because when we factored this, x minus 2 times x minus 2 is how you factor it. You get the solution of x equals 2 twice. And we talked about what happens then is the parabola is going to bounce off the x-axis at that point. Later on, like next semester, we'll talk about why that occurs. It's called multiplicity. So we'll revisit that. Then here in this question, this parabola crosses the x-axis twice. Also, by the way, this one had one solution. And this has two solutions. We're going to revisit this concept at the end of our quadratic formula lesson here. But first, let's talk about the quadratic formula. It's a hoot. So this is a quadratic equation in standard form. But the way we can solve the solutions or find the solutions of any quadratic equation is we could use our coefficients of a, b, and c and plug them into this quadratic formula. For a good time, we could derive the quadratic formula. It's just a completing the square question. But it's pretty complicated because of the nature of having an a value in front. So maybe for another day, maybe like right before winter break, we'll decide to derive the quadratic formula. Alright, so we have to remember that in order to use the quadratic formula and look at the coefficients for a, b, and c, you have to be in standard form. So that's the first thing we're going to check in all of our questions is the quadratic in standard form. So here, if they're calling it number 12, I must have stole it from another worksheet. It is in standard form. The a value is a 2. The b value, the coefficient here, is a 1. And then the c value is the constant, which is a negative 5. So using quadratic formula, the solutions are x equals, and it starts off with the opposite of b. So the opposite of our b term is negative 1. And then there's a plus or a minus symbol, meaning we're going to both add and subtract. That's how we're going to get two solutions for most of these. And then 1 squared, which from here on out, instead of writing 1 squared, I'm just going to write 1, or whatever it is when I square it. Minus 4, which is part of the formula, times a times c. So a is 2, and c is negative 5. And then that entire fraction, including the negative 1 in front, is being divided by double the a value. So when we go to simplify this set of solutions, because it can be a little complicated, what we're going to do is we're going to leave the negative 1 part in front there, leave the plus or minus, leave the square root symbol, but I want you to calculate what's called, we're going to learn this in a minute, the discriminant. So this guy right here is the discriminant, and if you could just simplify 1 squared minus 4 times 2 times negative 5 on your calculator would be fine. I think that ends up being a 41 when you type that in. And then we're also going to simplify the denominator here. Instead of 2 times 2, we'll write that as a 4. So the last thing we have to determine is if the discriminant that's currently being square rooted still, if that reduces in any way, just like we did with the square root lesson. 41 doesn't have any perfect squares, so we're just going to leave it as square root of 41. So this is our set of solutions. I hope you notice that you do have two solutions there. You have negative 1 plus the square root of 41 over 4, whatever that is, something gross. It's an irrational answer. And then you have negative 1 minus the square root of 41 all over 4. So if they wanted you to separate the answers, and you'll see the computer program that I sometimes print worksheets from does this, and it separates them like that, that's what you'll be looking for. Alright, so the next question is similar in style, where we have to look at the quadratic, the original setup, and make sure it's in standard form, which it is, ax squared plus bx plus c. So our a value is a 4, our b value is 1, again, and our c value is negative 3. So plugging in all those clues into the quadratic formula, you start out with the opposite of your b term, so negative 1, plus and minus, square root symbol, and then instead of saying 1 squared, if you don't mind, I'm just going to say 1, because that is 1 squared. It's not going to matter so much when your b is a 1, but in a minute we'll see why it's important to do that step in your head. Minus 4 times a times c, all over double the a value. So we're going to simplify this in stages, starting with the discriminant. So leaving the negative 1 plus and minus and leaving the square root symbol, you would simplify this guy right here. So let's see, 16, 48, 49 I think. So it's the square root of 49. I know it's going to reduce, we're just not there yet. And then the other thing I want you to simplify is the denominator, let's call it an 8. So here we're not done. A little bit of bad news. The square root of 49 reduces, and it is a perfect square, so it actually reduces to a 7. So we have, well, negative 1 plus and minus 7, all of that being divided by 8. Now since you no longer have an irrational answer, you have two rational answers, I want you to go ahead and find them. The first one being negative 1 plus 7 over 8, which is, and remember if you're typing it on your calculator, you need to use parentheses around that, but that's 6 over 8, which is 3/4. And then negative 1 minus 7 all over 8 is negative 8 over 8, which is negative 1. So two solutions you get are 3/4 and negative 1. Because we ended up with rational answers, what that tells me is this quadratic could have been solved through other nice methods like factoring. So rational answers mean I could have factored it. They didn't want me to do any other method, but just we're going to do a fun worksheet later on where you're going to choose whatever method you want. And fun fact, most of you are going to choose factoring if it's an option. So let's see, I think if we did plus 1 and minus 3 here, that's the factorization for this quadratic. And look at that, it's going to give you the same two answers. So what's nice is quadratic formula will always work regardless of the niceness of the answers. Alright, first step in number 16 is make sure it's in standard form, which it is. But I do notice something that might make my life a little easier. Do you notice they're all divisible by 3? So since it's an equation and 3 is just a coefficient, I can actually do that. I can divide everything by a 3 and give myself a much smaller quadratic. The idea is if you don't divide by 3 now, you're going to have to divide by 3 at some point in the problem. And I'd rather just do it now and get smaller numbers. So our a value is a 1 this time. Our b value is a 4. And our c value is a negative 4. So using my reduced version's coefficients, quadratic formula starts with opposite of b. So in this case, it's opposite 4, plus and minus, square root symbol. And then this is a case where instead of writing 4 squared, I'd rather you just write a 16. Minus 4 times a, which is 1, times c, which is negative 4. And then all of that fraction being divided by 2 times a. So simplifying this in stages, we're going to leave the negative 4, leave the plus or minus, leave the square root symbol. If you could please calculate this discriminant, which is 32. So it still says the square root of 32, and then 2 times 1 is really a 2. Okay, a little bit of bad news, we're not done, because while square root of 32 is not a perfect square, it is reducible. 32 is 16 times 2. So I'm going to reduce this into negative 4 plus and minus. This is 4 square roots of 2. Oh man, double bad news, we're still not done. If you notice all of your coefficients, I'm talking about the numbers in front, or just integers, if they're all reducible or divisible by the same number, you need to go through and do that. So these are all reducible or divisible by a 2. So this first term becomes a negative 2 plus and minus. This 4 becomes a 2. Square root of 2 doesn't change because that's not the coefficient. And then this 2 becomes a 1. So it would be best if you set your answers up just looking like this with a little x equals in front of it. And you have two irrational answers, negative 2 plus 2 square roots of 2 and negative 2 minus 2 square roots of 2. Lovely. Alright. Oh man, bummer. This one's not in standard form. So right away we need to do a little manipulation of the equation. 7x squared minus 2x, and then add that 25 over. So now our a value is a 7, our b value is a negative 2, and now the c value is a positive 25. So it's very important that you catch that manipulation of the equation off the bat. So using our formula, opposite of our b term is going to be a positive 2 this time. And then we're going to add and subtract the square root of the discriminant. Now here, instead of saying negative 2 squared, because a lot of kids mess this part up, because when they type this on their calculator, it gives them negative 4. We have to remember that when you're squaring a negative 2, you're squaring both the negative and the 2. So I'm just going to write that as a 4, so I don't have to even worry about using any parentheses on my calculator in that step. 4 times a times c is the rest of the formula, over 2 times a. So the a value, remember, was a 7, and then c was a 25 this time. Alright, so, oh, yuck. Alright, 2 plus and minus to calculate the discriminant here. Oh boy, I don't have a calculator with me right now, so a little quick handy work here. This is 100 and, okay, ew, what's going on here? I think I'm going to probably end up changing this question, so sorry. Because right now, this question is going to come out with an I in the answer. You don't know what an I is yet because we haven't learned that lesson, so I apologize. Probably what's going to happen, and I'm going to change it now. So I'm going to make this a positive 25 in the original problem, which means I'm going to make this a negative 25 right here. Sorry about that. Alright, so that's now positive 704. That did not turn out nice. Alright, over 14. Let's see, 704, not divisible by 4. I don't think it reduces at all. So, I think, well, is it divisible? Oh, it is divisible by 4. This is where I really wish I had a calculator. Alright. Oh no, bigger. Alright, I'm going to go dig for a calculator for a minute. Hang tight. So I could tell through that first division step that, 4 wasn't going to be a big enough perfect square. I'm going to go bigger with like a 16. Still not big enough. I'm going to try 64. Because 44 still has a 4 in it. That's how I knew. Fingers crossed. This is the one. There we go. So 704 is 64 times 11. Okay. That was a nice trip down memory lane, wasn't it? So this is really the square root of 64 times the square root of 11, and we know square root of 64 is really an 8. So our solutions right now are 2 plus and minus. Instead of square root of 64, I'll say that's an 8 times the square root of 11 all over 14. And we're still not done because look at all your coefficients. These can all be divided by a 2. So this becomes a 1, this becomes a 4, and this becomes a 7. So my solutions that I would like you to show are 1 plus and minus 4 times the square root of 11. Both of those solutions being divided by 7. Yuck. Alright. Apologies for the typo there. I hope I catch that before I teach the lesson. Alright. So let's revisit that concept of the word discriminant has come up a few times during this lesson, but remember our first concept in the lesson was if you want to know how many solutions your quadratic has, your discriminant can actually help you with that. Now think about this. In the quadratic formula, we have some number, and then we add and subtract like some other number after we square root it. So if the discriminant, which is just b squared minus 4ac, that's the thing that's underneath the square root symbol, if it's 0, then what's going to happen is you're going to be adding and subtracting the square root of nothing, which is 0. So you're not going to be adding or subtracting anything, meaning you're going to get the same solution and then get the same solution again. So you only have one, which is called a real solution. If the discriminant is something positive, so you take the square root of some positive number, you're going to end up with 2 answers. I'm not going to promise that they're pretty, but they are going to be 2 real solutions. But if you end up with a discriminant that's negative, like trying to take the square root of a negative number, we're going to learn in our next unit that when you take the square root of a negative, you get what's called an imaginary number. Now you're still going to be adding and subtracting that imaginary number, so what happens is you get 2 imaginary solutions which means we have no real solutions. So that previous example that I apparently had a big typo on, it's not going to, originally, before I changed the typo, it would have produced 2 imaginary solutions, and since you guys don't know about imaginary numbers yet, you gotta wait till the next lesson. You wouldn't be able to solve that one, so my bad. Alright, so this next set, I just want you to figure out the number and types of solutions based on the discriminant. So all I need you to calculate is b squared minus 4ac, the thing that would have gone under the square root in quadratic formula. What this does also is it allows you to determine what method of solving is most appropriate. So negative 6 squared plus 4 times the a is 1, the c is 9. So we end up with 36, positive 36, minus 36. So you get a discriminant equal to 0. And remember back to our chart here, if the discriminant is 0, that means you get 1 real solution. You can abbreviate solution like I do. So what that tells me, if I was given the choice of how I want to solve this quadratic, I mean, you're already half done with quadratic formula, so you might as well just keep going. But you could have factored it. You could have done completing the square. Both would have given you pretty nice answers. Alright, so discriminant here, negative b, or sorry, not negative b, b squared, which is negative 6 squared, minus 4 times a times c. So we get 36 minus 72. Alright, so we get negative 36. And if you get a discriminant that is negative, that means you would have been square rooting something negative, which means you get, you could say 0 real solutions, or you can tell me you get 2 imaginary solutions, which we will talk about in the next lesson. And then, this next part, b squared, so negative 6 squared, minus 4 times a times c, 36 plus 36, which is positive 72. So if your discriminant comes out to something positive, that means you have 2 real solutions. So there were the 3 cases right there illustrated. Discriminant of 0 gives you 1 real solution. Discriminant that's negative is going to give you imaginary solutions. And then a discriminant that is positive gives you 2 real solutions. Oh, that's the end of the lesson. So what's going to happen next is we're going to discuss what imaginary number system looks like and how we can use that to solve all quadratics, even the ones that produced non-real solutions. So we can come back to that question that I had a typo on and do it for real this time.